Alright, so in the last few videos you've heard me say parabola a couple times. I accidentally skipped this slide. So just kind of talking in general about what a quadratic looks like. This is a very basic quadratic function. Quadratic, think about degree when we learned that in polynomials. Their degrees are always 2 for a quadratic. So it could be a monomial, polynomial, whatever. As long as the degree is 2, it is considered a quadratic. We call the curve graphed by a quadratic function a parabola. And so you've heard me say that when we graphed this. I might have said it on example 2 as well. So all of these shapes are called parabolas. If you think about a water fountain, when it comes out like this, that is a parabolic arc. That's parabolic motion. When you shoot a basketball, leaving your hand to the hoop, that is parabolic motion or a parabolic arc. So this curve that a quadratic graphs is called a parabola. You definitely want to make sure you have this in your notes. Alright, so now we're going to look at the last 3 graphs that we've done. And we're going to look at which parabolas were facing down, sad face, which parabolas were facing up, happy face. So let's go back to this one. So notice here, this value in front of x squared is positive 2. And what is this parabola doing? Facing up. Example 2. This value in front of x squared was negative 2. What is this parabola doing? Facing down. And here, last example 3, your value in front of x squared is negative 3, and it's also facing down. So what did all of those have in common? Well, when the a value was negative, when it's a negative number, that creates a downward facing parabola. When a is positive, it is an upward facing parabola. So what is this a I'm talking about? Think back to those factoring methods we did in chapter 7, and there was this one. A, B, and C are just your coefficients, and this is considered standard form for a quadratic. So a is always the coefficient in front of x squared. So these are 2 quick bullet points about exactly when to know facing up or facing down. So in math, when we say a value is greater than 0, that's all the positive numbers. It's a quick shorthand way of saying positive, and this is a quick shorthand way of saying negative. So when the parabola is opening upward, that means a is positive. When the parabola is opening downward, that means a is negative. Okay? So let's look at some examples. Thinking back to polynomials for a brief second, we talked about standard form. And standard form was when you put the highest degree term first. Standard form for a quadratic is the same ax squared plus bx plus c guy. So we don't ever want to do anything with a quadratic until it's in standard form. So, does this open up or down? Well, let's look at a. A here is negative 4. Side note, b would be negative 1, c would be 1. But I'm only looking at a to decide up or down. So this is going to be down. It's going to look like this. Okay? Alright, so this one, be careful, because we don't, once again, want to assess any information on a quadratic until it's in this standard form. So I'm actually going to add 5x squared to the other side where everything else is. This would cancel. I'm left with y equals positive 5x squared plus 2x minus 6. And so now we have put this in standard form. Remember, in our unit on polynomials, we learned when we can add things and when we cannot. X to the first power and x to the second power are not like terms. So we are not going to combine those. We're just going to string them out in standard form. So now back to this question. Does it open up or down? Well, what is A? A here is 5. So that means it faces up. All right. Last little characteristic for this section 8.1 is the highest or lowest point on a parabola is the vertex. So back to talking about whether something faces up or down, if we have a parabola that looks like this, our vertex is here. If we have a parabola that looks like this facing down, our parabola is here. So when you have an upward facing parabola, your highest or lowest point, this would be your lowest point, is your minimum. You might want to give yourself a sketch of this picture. And then facing down, what do you think that vertex is going to be? It's going to be a maximum. Okay, so make sure you have what the vertex is called, and a vertex can be a max or a min. It's going to depend on how your graph looks. You can only have one vertex for a quadratic function. So we talk a lot about this point. All right, last page for 8.1. If I give you a graph of a quadratic function, which there's 2 here, can you tell me the vertex, an ordered pair? And can you tell me if it's a max or a minimum? So definitely make sure you make a note that the vertex is an XY coordinate point and that it's either a max or a min. It's not both. Alright, so you might want to sketch this in your notes. I wouldn't spend too much time on it, but let's go through this together. Identify the vertex of each parabola. Well, this is the vertex. It's that highest or lowest point. In this case, it's the highest point, so it's going to be a maximum, and I'll just abbreviate max for that. It also wants you to, well, I guess I did the second part of those directions. That's all good. It wants you to identify it by telling you the coordinate points. So this coordinate point is going to be 1, because that's the x value, 1, and the y value at 5. So 1, 5 is your vertex. And that's your answer. It's maximum at 1, 5. The vertex is a maximum at 1, 5. All right, over here, this is going to be, you guessed it, a minimum, and we're going to abbreviate it that way. Your x value here is -2. Your y value is -2, -3, -4, -5. And that's your answer. So a vertex will always be an XY ordered pair. Okay, so let's check in with ourselves. Let's make sure we understand everything that 8.1 has to offer. What is a quadratic function? Knowing this answer from given a table of values. Or understanding that a quadratic function always has a degree of 2. So side note, y equals 3x plus 1, not quadratic. That degree is 1. That's actually a linear function, right? We spent so much time on linear functions. What else? We talked about creating a table of values. Make sure you understand that. And vertex, max, min. And that ties into whether your parabola is facing up or facing down.